So what I'm looking at here is we have a second order homogeneous differential equation. This is the second video in this series. The first one, we did an introduction to the homogeneous differential equations, and we looked at the discrete, distinct, not discrete, the distinct real root case. And today we're going to look at the repeat real root case. And this problem, we have the second derivative of y plus 16 times the first derivative of y plus 64, y equals 0. Okay, and we have the problem on the board. So what we'll do, our first step is to turn this into the characteristic polynomial equation. So we'll have r squared plus 16r plus 64 equals 0. And we'll just factor that. That's just going to be r plus 8 times r plus 8. The factorization of that, and we can write that as r plus 8 squared. So clearly we're getting repeat roots, and that repeat root is going to be minus 8. Okay, good. And then what we can do next is we can try to put this into the form of a solution, but you'll quickly see the problem that we have. We have our first part of the solution, but for the second part, if we try to use the same root, this doesn't make sense, because if these are arbitrary constants, and if you just kind of factor out the exponential, this is just one arbitrary constant, so we're back to just this. So for a second degree differential equation, we need the two parts to the solution. This is not the complete solution. So we'll have our first part of our solution, and then we'll have C2T. And it's kind of crazy, but the thing to remember is that you can add a t to the expression for the repeat root. So this would be our solution. And let's see what we can check our answer. This one here. Look at. That's correct. So that's the basic idea of the repeat root case. It's actually a pretty simple trick to add a t, and that would even work like on a if this was a cubic or a higher degree, you could add, if you had three roots and they were all the same, you could add t squared and so on. So it's pretty straightforward. You need what you do in those cases. And so I have the help down here on the quiz, and I just briefly touch on it. It's not too different, once you know how to do the unique. I should have said distinct there, not unique. Anyway, I have to think about that. But yeah, so I'll provide a link to this quiz in the description. And if you want to try some of these problems, it's going to be a mix of the real case and the complex case. In the next video, we'll go over the complex root case.